So thank you for joining our session. We'll be talking about adopting Theia to support multiple perspectives on a single data model. And we will go a bit into the background story of CrossModel, data modeling product, demo, and some technical architecture. And of course, there will be some AI involved. So I'm Harmen Wessels. I'm the product manager of CrossModel at CrossBreeze. And during the session, I will talk about the background and the functionalities which exist of CrossModel.
Hi, I'm Martin. I'm a lead software architect at Eclipse, and I've been with the CrossModel project since the beginning. And later, I have the pleasure to give you an overview of the technical architecture that we actually implemented.
Yes, thank you. So first off, I'll start with a bit of background of why we created CrossModel, because I'm working for CrossBreeze and we are specialized in creating data solutions like data warehouses. And in these projects, we apply model-driven development and code generation to automate most of the data engineering work. So instead of building everything by hand, we maximize automation to increase the quality, agility, and auditability, while at the same time having a shorter time to market. And to achieve this, we have a standardized process, which we call model-driven data engineering, where we separate the what from the how. And the what means a data model, where we capture the required data structures, data flows, which we call mappings, business logics, and examples. And together, this is all the specifications of the system to be implemented. And then the how part, those are the templates. These are the technology-specific parts of the solution where we have templates for database code, ETL, test scripts, and documentation. And if we feed the data model and the templates into an artifact generator, we can generate all database code, ETL, test scripts, and documentation. And as you can imagine, in this way of working, the model itself is the most important asset of the product in this process. So we are very dependent on a great modeling tool. And of course, we first tried to use modeling tools which are already available in the market, but we have some problems with that. First off, we cannot capture all the needed metadata to generate the code, because if you can imagine, if you want to generate all the code, you need a lot of metadata. And there are quite a lot of modeling tools which don't support capturing data flows on a logical level, or you cannot define custom properties which you might need in your model to generate. And second, the modeling tools itself are quite closed by nature. So you have very nice forms and diagrams to model your data model, but it can be quite hard to get to the underlying metadata, which you need, as you seen in the previous slide, to generate the code from. Sometimes it's a binary format, it's stored in a database, proprietary database, or it's a very complex XML format. So that can be an issue. And the last thing we saw is that the modeling tools which exist are not created for agile teams like DevOps teams or model ops teams, where modeling itself is part of the development process. So those modeling teams usually have their own version control mechanism, very disconnected from the code and the development process. So we thought, how can we do this differently? We want a modeling tool with a clear vision that everything in the modeling tool itself is a perspective on a single truth, which is the data model. And if you're a human, you can look at it from a form perspective to enter data, or you can have diagrams to make data modeling. But you can also imagine that sometimes a textual perspective is very easy. For example, if you want to do find replace or copy large bits of the data model and then edit them, that's very easy. But then we reckon there would also be a second type of user of the modeling tool, which is the computer itself, because it would be very nice if we can get to the metadata of the data model via a programmatic way, which also requires a perspective on your data model. So with this vision, we thought, okay, let's make this reality. So we made some screen designs, created requirements, and one of the main principles we started off with was not to reinvent the wheel. So we went on a quest to find a base framework or platform which we can use to build CrossModel on. And after some research and some sessions, we landed on Eclipse Theia as our choice because it ticked a lot of our boxes and it had a lot of components in its ecosystem which we needed or might need in the future. So now we're at the stage where we actually build it. So I can show you a demo of how we implemented the vision, the unified perspectives in CrossModel. So we're looking at CrossModel right now. We have two data models open, the ERP source system and the data warehouse. Within a data model, you can define diagrams, entities, mappings, and relationships. And if I would open the product entity, for example, we can have a look at it from a form perspective. You can see a list of attributes. And here I want to create a new attribute. So in this case, I will create an attribute named create date. And I change the data type to date. And now we can switch to the code editor to look at the same entity, but then from a textual perspective. And you can see that the create date metadata is already there. And it's being kept in sync. We can also create mappings on entities. So again, we look at the product entity. So we look at the product mapping. And a mapping is a definition of data flow from source entity to target entity. And as you can see, we've already created some attribute mappings, but for the new attribute, there is none yet, of course. So we create one using the create mapping tool. And then we drag the source attribute into the target. And with that, we've captured the lineage. But as you can see, the source data type is date time and the target is date. So we need some extra logic for that. So we go to the code editor. You can again see that the attribute mapping is already there. It's in the code. But now we're in the code, it's quite easy to add the expression we need in order to convert the source data type to the target data type using a cast expression, which is a ANSI SQL expression to change data types in a SQL format. So that was quite easy to do. You also saw some auto-completion on the attribute. And if we go back to the mapping, you can see there is a FX icon next to the attribute mapping showing that there is an expression. And if we go to this widget, you can also see the expression in the property editor. So all perspectives are always kept in sync. Now, if you go to the diagram perspective, which is again a different way of looking at the data model, we see three entities of which the product is there again. And if I look at it, I don't like that the attribute is called ID. I would rather have it named identifier, fully written. So I just use the textual find replace to replace the ID name with identifier. And as you can see in the diagram again, it's automatically updated and being kept in sync. The diagram also has a code perspective, and that shows the position of all the entities, which are the nodes and the edges. So that's also being kept there. And then if we go to the Git tab, so the version control, we again have a perspective to view the changes we just made in the textual format, which is standard Theia, but it's just nice that this is all being made possible by the platform. So now we've seen a bit about the background and what we've built. I will hand it over to Martin to explain how all this works under the hood.
All right, thank you, Harmen. So we have already heard the mantra, everything is a perspective, but of course those perspectives are realized using different UI technologies. So for the form perspective, we are using Prime React components. For the graphical perspective, we are using the Eclipse GLSP framework under the hood. And for the textual perspective, we are relying on the Theia native Monaco editor integration. Of course, what is Much more interesting is how are those different perspectives actually synced. As Harmen already said, they all need to kind of work on the same data source. So there must be some way they are all connected. And really the core idea of our architecture here is that we build upon the language server as a single source of truth. So if you're not familiar, language servers provide language-specific functionality, such as auto-completion, as we have seen, or validation, to a textual client by adhering to the language server protocol. So there's kind of a standard released by Microsoft, and there are already tons of different implementations for different languages in different technologies out there. So for TypeScript, Python, or whatever, you can find usually a language server. And it's also how VS Code integrates language typically. So the very good thing about the language server protocol is that it is a very clearly defined lifecycle, not only for the server, but also for each individual document that it manages. So very simply put, what you can imagine is that the client initializes the server, provides a workspace location. The server goes through this workspace location, parses all the relevant language files that we are interested in, and builds up a document store. So in our case, we parse basically the textual file. We get the abstract syntax model that matches our CrossModel language and have that in the store. But additionally, what happens is that the language server also builds up this kind of index of information regarding each document. So we know the URI, we know exactly what the exported named elements are, we know about the cross-references between the documents. So if you make a change in one document and it is referenced elsewhere, we make sure that all associated documents are updated as well. So that is all basically part of the language server. So if you have worked, for instance, on the Eclipse RCP platform with Eclipse Xtext before, you might be familiar with this kind of indexing. We are now on the TypeScript side, so we are using Eclipse Langium to develop our language in the language server. So I've already mentioned that the language server builds up this document store, and it has this in-memory representation through the abstract syntax model. But of course, that doesn't mean that the language server always holds all those models in memory all the time. So there is some kind of life cycle to each individual document as well. So what you can imagine is if you open a text file, or as we've seen Harmen opening the any file basically and switching to the text perspective, what happens is that the Monaco notifies the language client to kind of send a document open notification to the language server with the current content of the file. And from that moment on, the language server really is the one that holds the source of truth. So any changes, any typings that you do, go through this whole process and always update the language server. So we kind of get this live perspective on a particular document or file. And the syncing back, for instance, to the file system really only happens if you trigger an explicit save. So by using the language client and the language server, we basically have already taken care of the textual perspective through the language client VS Code Monaco integration layer that we have in Theia. But what about our graphical and form perspective? So the idea here is really that the GLSP server and the form server again act as an additional language client to the language server and adhere, of course, to the lifecycle of individual documents. So if you open the diagram perspective, for instance, the GLSP server will also trigger this open document notification on the language server. So the language server knows, okay, the document has been opened. I need to have this in-memory representation of it. And any changes that come through either of the clients will update my internal model, and I will send out events to all connected clients about those changes. Of course, that's the integration with the language server. There is some translation effort necessary for the different technologies. For instance, in Eclipse GLSP, the internal model is the G model. So we need to translate from the abstract syntax model that we get from the language documents to the G model and vice versa for any operations that we do. But that turned out not to be very difficult, to be honest. And for the form perspective, a form perspective, it is even the same and even simpler, because here we don't have already a protocol that is given by an external framework. We simply defined our own, and that is just a protocol that is very simple, and the model is basically the abstract syntax model stripped from any unneeded information and making sure that it can be properly serialized and sent to the form client in Theia. So there are two choices that made our lives a lot easier when implementing this architecture. So first, even though I say the GLSP server and the form server act as a language client to the language server, we did not start them as separate processes. Mainly because then they would fully need to adhere to the language server protocol, and we would also get this additional inter-process communication channel. So we thought, okay, we will all put it in a single server running in the same process, so we can kind of access some of the functionality a little bit more directly than we were if we were true external clients. And the second one, to ease our efforts in the translation, is that we always do full document updates. So that is not a problem for us. But basically what that means is we don't have to do this particular translation from, for instance, you move a node in the diagram to what specific line and column position does that translate into textual documents. We don't have to do this partial upgrades. We simply make the changes, serialize the whole model again, and basically send it as a full textual update to the language server. So these are really two things that made a lot of things simpler for us. And yeah, really, I would call it a benefit. And if we ever run into troubles, we can easily improve upon that. So what are further benefits of this architecture? As Harmen already mentioned, we have this single source of truth. In this case, it's in the backend, it's in the language server. There are already implementations out there for that. We used Eclipse Langium for the language server implementation. The document store is, I think, from VS Code itself. There's a package for that. We have seen that we can integrate several UI frameworks in the front end. Of course, there is a little bit of a translation layer necessary, but overall, we have this great separation here. So we already switched form framework once, actually, and it didn't cause any major changes in the backend whatsoever. So it could really just plug in another UI framework. Overall, the technology stack is quite simple. It is TypeScript all the way, from Theia frontend to backend to the VS Code extension that actually starts the server process, to the language server and the other servers as well. So it's all written in one language. And of course, the added benefit that we all get if we base our product or our application on Theia is that we can have multiple target platforms. So we can have it in the browser, we can have it as a desktop Electron application, we can even host it as a software as a service somewhere in the cloud, which again is the browser, but a little bit nicer. And yeah, it's basically all based on open source technologies. So really, reuse is super high here, and we're very glad that we picked this stack. So now that we've seen the architecture, I think we can have a look at how we actually extend CrossModel with AI assistance.
Yes, thank you, Martin. So while we were working on CrossModel, the core features, which we have talked about up till now, the hype of AI, of course, turned bigger, and we thought about, okay, what does that mean for data modeling? Because, of course, that also has an impact on how you can work with data modeling, or how that can improve the process. So we thought about it, and we thought, okay, it's probably the same as how it works with coding. So you can let AI do stuff for you, and then there is more focus on reviewing what it has done. So that's the same case for us. And thankfully, again, it's a new perspective on our data model supporting AI. So let me just jump straight into the demo. So we are in the same workspace again as we were in the previous demo. And so if we look at the diagram, we have 3 entities, but we have 2 mappings. So we have 2 data flows defined on the entities. And as you can see, for the stock entity, we don't have a mapping yet. So I can make it myself, but we have AI now. So let's open the CrossModel Assistant, and then we will ask the data modeler, so we will prompt it to create a new mapping for the stock entity in the data model, which we were looking at. And then we will ask it to use the entities in the ERP source system as a source, and then just let the LLM figure out, based on the descriptions, the attribute names, and all context which is already available in the data model, which is probably the most logical choice for creating a mapping. So we send out the question to the data modeler. It starts investigating the workspace. So it will have a look at the ERP source system entities. It will have a look at the data warehouse entities. And then it will think about it for a little bit. Give it a couple of seconds, still looking at some files, finding the patterns, and then now it concluded, okay, I know what to do. I'll create a mapping. So now it creates the mapping file because it knows what the grammar is of CrossModel. It validates the file, and now we see that the mapping has been created and it conforms to our grammar, so it's correct. So that's also being checked by the assistant itself. So it summarizes it nicely. So if we look at the mapping, you can see that it used 2 source entities from the source system. It mapped 4 attributes, and in the total value, for example, you see fx next to it. So it means there is calculation in it. And there you can see that it also automatically made an expression to calculate the total value of the stock. And yeah, that went quite smoothly. Also works quite quick. It was in real time, so there was no speed up or anything. So I was happy with that. So that's just one example of how AI can help you in data modeling. Another one is, which we tried, is feeding it an image of a data model, which someone drew on a piece of paper. And then we asked it to create the data model, and it easily reproduced the data model in CrossModel based on the image. So that was quite cool that works. We also reverse engineered an application database based on the database code and PDF, and that also works very well. So based on what we just saw, Martin will just explain briefly how that works under the hood.
So I will not go into too much detail here, because I think there are other talks that will highlight the more technical aspects of the Theia AI integration a little bit better. But basically, what we are doing is we are reusing the ever-expanding AI integration of Theia, because it actually yields a lot of very important benefits for us. So first of all, it bridges the communication to the LLM, so we don't have to care about any specific LLM API. That means that we can just plug in any off-the-shelf LLM, but also have enterprise level LLMs running for enterprise customers that want to run their own internal models for data privacy reasons. It provides this familiar chat-like UI that we have all seen now, which is very close to what we have in VS Code. It comes with a set of reusable tools that we are also using to allow querying and interacting with the application in the workspace. And of course, that all of these individual parts are also customizable. And one of those customizations really is providing a custom agent. So we have seen in the demo from Harmen that we have this data modeler agent. And this is what we're really doing with that, is providing a system prompt for an LLM that fits the needs of our application, gives it a little bit more context, so it can perform tasks for our particular use cases. We can see the prompt here a little bit. Basically, we have several areas. First, we give it an overview of the overall workspace structure and how the semantic content is supposed to look like. Then we have how the agent actually should behave, how it should think about the problem, and then how to combine those things to come up with a solution and propose that to the user. So in this case, we want to have an autonomous agent. So it really should only present a solution to the user after going a rigorous process of solving the complete problem. We can see that in the prompt a little bit here when we say only when everything is really done, please end your turn. But also in the final instructions, do not stop until all errors are fixed and no further action is required. So really what we need to have is this kind of feedback loop. And in our case, we can reuse what we get from Theia here, because there is already a tool function that gives the diagnostics of the workspace. And in our case, the language server actually provides the validation results of our application. So of course, that means it is very important that all our error messages, our diagnostics, do have good descriptive messages, that they point to the right area where the problems are actually happening. But with that, we can have this really nice feedback loop between the LLM and the tool functions and the AI integration, and only then a solution will be presented to the user. Yeah, so we have made quite good experiences with that, also with providing the overall description of the workspace as part of the prompt, giving it as an example with comments to kind of give additional restrictions instead of teaching it the grammar, which is also something we tried to do at one point, but this approach has yielded better results for us. So let's see.
Yeah, thank you, Martin. So lessons learned, I will keep it brief, but when we started with adopting Theia, or at least we saw a lot of videos on YouTube of Theia, so we thought most functionalities we could use, but there were a couple of them which we couldn't, because we have chosen for a full TypeScript backend, and some functionalities are only supported by certain Java backend components. But the majority of the functionalities could easily be built on Theia, so we're still very happy with that choice. Implementing supporting multiple perspectives on a single model works great, as you have seen. And at some point, we switched from Movie to Prime React, which of course was a little bit of work, but because the architecture was set up this way, it was a very it was simpler than maybe in other scenarios. So that was awesome. And I also think that the combination of Eclipse Theia with GLSP and Langium is a great fit. They just combine great together, as you also saw in the architecture picture. And we're definitely picking the fruits of the Theia community efforts. Like when we wanted to adopt AI, there was Theia AI, and we could just build a first version of our AI agent just within a couple of hours. So that was definitely something which we were very happy about. So I think that summarizes our lessons learned. So thank you, and I'm curious whether there were questions.
Thank you both very much for the great presentation. I'm going to take a quick look here to see if there's any questions. And we do not have any questions. So again, thank you so much.